Hi, Alan Stratton from Woodturning. I didn't make it to AEW Symposium this year, but I did see the videos, one of which was by Michael Anderson, where he did a captured pedestal spin top. Well, after I made it, I was intending to show you a video of making it, but then after I made it, I said there's got to be an easier way to do this. So I did. That's what I'll show you in the video, which is this one, which I think is at least easier to make. I don't know whether it spins better or not. But one of the tools that I used in this that I don't frequently use is a collet chuck. A collet chuck is a fairly simple piece. It's much smaller and actually less expensive than a big chuck, but it uses a collet for each size, and those go together, and then you are able to hold cylindrical stuff in your lathe. However, I have had this for a long time. One of the problems with this set is that it is graduated in eighths, and the range of a collet is actually fairly small, and I needed one that went a little bit finer. So I actually went to Amazon and bought a set that increments by 30 seconds. That works much better. So you'll see those in action in this video. So let's get to it and make our own spin top with a different mechanism that I think is easier, more able to work it to where you can make it work for you, and I think better. But having said that, I'm sure that as soon as I publish this out there, some of you will come up with an even better idea for a captured pedestal spin top. I want to hear what you've done also. So let me know, and let's get to it. So let's make this captured pedestal spin top. I want to give a preview of how this captured pedestal spin top design goes together. My hope is that this design has two significant advantages over the AEW demonstration design. First, the critical pieces are separate pieces of wood. These can be tested independently and made over, if necessary, without starting the whole project over. Second, no nearly impossible parts to assembly. The body is whatever you want. Its only design features are a mortise to fit the capture block and a through hole to receive the finial or handle. The only important note about the top of the pedestal is that it must be carefully sized to barely fit into the capture block. The rest is whatever you want. The capture block is turned separately and can be redone if a mistake is made. It has a through hole that does double duty. From the top, it receives the finial or handle. From the bottom, it holds a point that the spin top spins on. At the bottom is a tiny hollow form that allows free rotation on the pedestal, and that is a very tight fit to the top edge of the pedestal. The point is on a piece of dowel sized to fit the through hole in the capture block with a point for rotation. Originally, I had wanted to put a small round tack head, but the tack was smaller than my smallest drill, making it nearly impossible to center. So I simply pointed the wood. Both the tenon on the finial and the point are prepared long and shortened during assembly. I'm starting with the capture block. I've turned down an oak dowel to exactly 3/4 inch and now have mounted the dowel in a collet chuck. First off, I drill a 3/8 inch hole with a Forstner bit to about 1/2 inch depth. Then switch to a 1/4 inch drill and drill completely through the dowel. A bit of cleanup on the end with the skew, and I'm ready to hollow the end of the dowel. Using a small carbide cutter, I reach in beyond about 1/8 of an inch and hollow down to a depth that I drilled the 3/8 inch hole to, leaving the walls about 1/8 inch thick or less. I have to make sure I do not cut away the neck opening. That was easy, but I will check it later with the pedestal and remake it if necessary. Next, I have a block of ash mounted in a standard chuck. I reduce it to a size that looks good to me, about 3 inches. Then estimate the depth that I want to hollow the wood, plus a little more for a mortise. I mark the depth with tape on a drill and drill. The exact depth is not critical, but the little extra is critical since we need a mortise to receive the capture block. I mark the depth of the drill on the outside of the ash, plus more for the mortise and a little bit more. I want some strength here, and a little mass will not hurt. After parting down at this limit to preserve the mark, I can shape the outer profile of the spin top body. I am choosing a bead at the bottom and a smooth profile from there to the top. Then hollow with the spindle gouge cutting outward and clean up with a round nose scraper. Then sand. After sanding, I burn a line at the top of the bead with my wire tri-burner. I touch the wood again with 400 grit to smooth the burn line. Then apply shellac friction polish to the inside and outside before parting off the spin top body. Using the base of the ash, I cut a tenon on the end to fit the bottom of the spin top body. This forms a bit jam chuck. This is more safe for the wood finish. Steel chuck jaws could damage the finished wood. With the wood pressed onto the jam chuck, there is very little left to do. Clean up the top and apply shellac. Next, I have remounted the capture block in the collet chuck. I measured the depth of the hollowed portion plus enough to hold the future point dowel, plus or minus so that the capture block will be hidden inside the spin top body. Then reverse the capture block and part off the excess. Since the capture block is exactly 3/4 inch, I do not need to cut another tenon. The capture block is the tenon for itself. I may as well turn the finial now. I have a small block of unknown wood mounted to the long nose jaws. It turns out to look like a variety of mahogany. After roughing it round, the objective is a perfect 1/4 inch tenon, longer than what I will need for the final top, because it will also serve as a mounting tenon to a collet chuck. After finalizing the size, I shape just a little bit more so that I can sand and finish this without it being immediately next to the chuck surface. Then sand and apply shellac, but not to the tenon portion that will be inside the body and capture block. Next, reverse the finial into a 1/4 inch collet chuck. I want a minimum finial or top so as to not overweight the balance. Final shape with the skew, sand and finish with, you guessed it, shellac. Now for the tiny point portion. Dowels are rarely sized exactly, so this is mounted to a slightly larger collet while I turn the dowel down to 1/4 inch. In previous attempts, I tried to drill for a brass pin, but the pin shank was smaller than my smallest drill, so too sloppy. I also tried pounding a pin in with a hammer, again too sloppy. I settled on a simple point, then sand and apply shellac before parting it off longer than I think I will need. I test the length during assembly. Now for the pedestal. The remaining ash looks big enough. The extra diameter at the bottom will extend the base for more support. So I'm off and turning with my bowl gouge. But wait! I need to fit the top of the pedestal to the capture block. This is the tricky part. The pedestal needs to be slightly larger than the hole in the capture block so that the capture block can be pressed on and only removed with corresponding pressure. The top lip must be small enough to fit inside the hollow portion of the capture block. The top centers should be flattened or slightly dished for the point to spin on. If I blow this, I will have to either adjust the pedestal or the capture block, but at least not to have to redo everything. After sanding, I decide to cut a very shallow tenon so that I can reverse the pedestal while I complete the bottom. This cut is skew work for me. I decide to burn this to correspond to the burn on the top's body. Then final sand, apply shellac, and retest with the capture block. Whew! Now reverse the pedestal using that shallow tenon while I finish the bottom side. However, I was too aggressive on the spindle gouge. A whoopsie. The pedestal decided to fly away. Fortunately, no damage. I remount it, this time with the live center in place. No more spontaneous flights, but just in case, I cut a very shallow mortise on the bottom side in case I need to clean up the top side again. Sand and apply shellac. Turns out there was a little damage, so here's my penance. The mortise fits the long-nosed jaws. Live center pressure with the point padded with a rubber stopper allows me to clean up the damage. And again, sand and apply shellac. Now to assemble. I start with the pointed dowel inside the capture block and estimate how much it needs to protrude to have enough to spin on. I also estimate how much more to shorten the other end of the dowel to allow room for the finials tenon. After positioning the point, I drip on a little CA glue and let it harden. The capture block is a tight fit for the spin top body. I do not need to glue it. Then shorten the finials tenon by gluing it into the spin top body and capture block with wood glue. All done. An easy assembly. Much easier than the AAW demo assembly. Even after making 2 of these, my favorite is a simple 1 or 2 pace spin top that only takes 10 to 15 minutes to turn. The collet chuck played a key role in this project. However, I do expect several of you viewers to come up with an even better captured pedestal spin top. Just let me know. A note on my collet chuck, ER32 collets. I purchased this years ago in a closeout special. I tried to use it on a couple of dowel-based projects. However, since dowels are usually oversized, they did not fit the range of collets in my set. Frustrating. I went to Amazon and found a set of ER32 collets with 1 32nd inch increments. This should fit about anything that I will want to use up to just over 3/4 inch. Total price is less than a new chuck body. A wood-turning collet chuck is hard to find, but they are out there. Otherwise, an M2 tapered collet with a drawbar works, but is more fussy to change. Meanwhile, please give this video a thumbs up and subscribe to my website in addition to subscribing YouTube. When you subscribe to my website, I send an email when there is a new video. Please share my videos with your friends. I keep these videos short and to the point to respect your viewing time. I always appreciate your comments and questions, and please wear your full face shield whenever the lathe is running.